Hey, Chan Physics, Mr. Block talking to you about horizontal projectiles. One of the toughest things that we're going to learn this year. So I know it's hard in week 5 for you to believe that this is going to be the toughest things, but it is. First of all, for those of you guys who are just starting, you're going to look at this problem set and you're going to go, okay, what does this look like when it's done? And if I show you what it looks like it's done, it looks like this when it's done, okay? And it looks like all of this. And so a lot of you guys will be turned off by that just to begin with. You're just going to be like, oh, I don't want to do this, right? But the reality is that, as I told my classes, it is a really good effort for your brain to learn how to juggle these two variables. And in life, you have to juggle 5, 6, 7 variables at once. And our young brains aren't ready for just two. So just doing this problem set is just a tremendous learning experience. But number two, if you do it the way that I told you as I talked to my classes, we're going to learn a method that's a little bit different to do studying. A lot of you guys do studying and you say, oh, test me, or you do like 1 or 2 problem sets and you kind of learn it. But we're going to learn something that I learned when I was taking the bar, and that is to do the same thing for a problem set in the same place of a piece of paper. And when we do that, our brains learn that this space is for this activity. And they actually then remembers the algebra, remembers the equation set. Your brain is ready to say, okay, I'm ready to do this in this spot. And we learned how to do this for the bar exam with just like 3 months of studying. And we were able to get it down to 6 pages, and then we were able to learn it that way. And so for this very small set, we're going to try this different way of learning, and that is I'm going to ask you to do the things that I teach you in this problem set in the same spots that I do. And then when you do the repetitive problems, you're going to repeat that over and over again. And so that when you get a problem in a testing situation, you're going to do it in the same place. You're going to say, okay, this spot is for this, this spot is for this spot is for this spot is for this. And your brain will be more apt to remember the equations, the algebra, and the thinking that goes in there. Okay, so I'm going to do the first problem just on this blank sheet of paper, and you're going to see that we're going to repeat it, so that I'm going to give you guys the key in a second. But the key is posted. And so the first thing we need to do is we need to orient ourselves with the idea of what's happening in the problem. The cannon is going to shoot this ball directly to the horizontal, so directly this way. It won't have any part of the initial velocity. None of it's going to go up, none of it's going to go down. It's going to go straight across to the right. That's why we call it a horizontal projectile. And when it does that, we know as soon as it gets off of the cannon, it's going to start to fall. All right. Now, the first thing that we did in my class was we learned that no matter what, how fast this falls, this ball is going to fall just as fast as if we drop it. So if we drop a ball or we shoot a ball, they land at the same time. This is really hard for our brains to function. And so if you get a chance, come to me. I'll show you a video of it happening. But it's true. And it's even true for a bullet. So if you shoot a bullet this way and drop a bullet at the same time, we can show you a Mythbusters that shows that the bullet actually lands at the same time as the bullet lands here. And we just don't think that. We think that if we put a lot of velocity in it, somehow it's going to stay up in the air. It doesn't. It doesn't. It drops just as fast as if we drop it. Okay? So how do we do these problems? Well, first of all, the problem can only ask a couple things. The first thing is it can say, what's the range? And the range is from here to here. So if you ever go to a driving range for golf, it's like, how far can I hit it? So range is just how far does the ball go, or how far does the projectile go? So that's number one. They can ask us that. Number two, they can ask us the horizontal speed. So right here, if I was to draw an arrow, just before the ball hits, it's got some velocity that looks like that. All right, that's the horizontal speed. And it's going to have some vertical speed. So it's going to look like that. All right. And remember, we add vectors tip to tail. And so the reality is when this thing lands, it's going to be at a diagonal, just like when we added those two vectors up. So this is Vx, this is Vy, and this is the range. Those are the three things that they can ask us. The one thing that they don't ask us for is the time. But you're going to learn that no matter what, whenever we do a projectile problem, we need to know the time. And so what we're going to do is we're going to list all of our variables here and find out what we got. We're going to leave this spot open to figure out how long it's going to take for this thing to hit the ground. We're going to leave this third row open to find the range. And we're going to leave this fourth spot open here to find our velocities. And when we do that, like I talked to you guys about, then we've oriented ourselves and say, okay, this is where we do this work. Okay, and it works very well for us. All right, so the first thing I do is I draw X and Y because the ball is moving in both the X and Y direction. And I list all the variables that I have. So VI, VF, distance, acceleration, and time. Those are all of the variables. And so now we need to read the question and ask ourselves, do we know any of these things? So it says the cannonball is being fired horizontally at 90 meters per second to the right. And so we know that if we were to draw what that looks like, to have that thing going at 90, that vector would look like that. It would look like a straight arrow to the right. So the X initial velocity is 90. But the Y initial velocity, there's no part of it that goes up and no part of it that goes down. And so the initial velocity in the Y direction is 0. Right? We're going to leave the final velocities because that's what they asked us to find. So we're going to leave that blank. And we're going to leave this distance right here in the X direction because that's the range and that's what they asked us to find. So we're going to leave that blank. And we're going to go back to saying, okay, do we know the rest? So the problem tells us that our cannon is 4.5 meters high. And so we know that the ball is going to have to drop 4.5 meters. And so the distance in the Y direction is 4.5. And we're going to put a negative to indicate that it's falling. All right, acceleration. One of the things that we haven't talked about yet is what happens when we shoot something and there's no air resistance. Will it keep going or will it just start slowing down? And the reality is, if there's no air resistance, the ball is going to keep going at 90. And except if there was like some sort of hand that comes in or something that will stop it, it will keep going forever until something stops it. And so if our ball in the X direction is going 90 and it does not going to get slower and it's not going to get faster, then its acceleration is 0. All right, in the X direction. But in the Y direction, well, we know everything falls at negative 9.8. So we put that in there. Now, we just spent a lot of time talking about what happens to a ball that's falling. And we said that they're going to land at the same time. And so we don't know the time for it to fall in the Y direction. We don't know how the time it takes before it hits here in the X direction. But we do know that those times are the same. And so in my class, we always just put a box there to tell us, once we find the time, we found it for X and for Y. Okay. All right, I'm going to go a little bit faster here. The second column in these problems, we find the time. And the time is defined by the Y direction. So I put Y direction to remind myself that I need to use these variables. All right, no matter what, if the ball lands after falling 4.5 meters, right, we know it's going to take longer if it was at 10 meters, right? And so the Y direction defines the time. And so what we need to do is we need to figure out what variables do we have. We have VI, we have D, and we have acceleration, and we need time. And so when we look at the 5 equations that we learned, the equation that works is delta X equals VIT plus 1/2 AT squared. All right, that's the equation that's going to work for us. We don't have the final velocity, so we have to use the other distance equation. We plug in our numbers. Negative 4.5 equals, well, what's VI? It's 0, right, in the Y direction, not 90, 0, because we're doing the Y direction. So 0 times time is 0, plus 1/2 times negative 9.8 times t squared. All right, we can make another real quick thing to make it easier on us. We'll just take 1/2 of negative 9.8. That's negative 4.9 t squared. All right, and that's where we're at right now. And so to find t, we divide by 4.9, negative 4.9 on both sides. All right, and we get t equals negative 4.5 divided by negative 4.9, right? But we had t squared, so to get t, we're going to have to take the square root of that. All right? And once we've done that, we know that t is going to be, let me look at this key real quick, 0.95. So t is 0.95. We can put that in right here. Okay? Did a lot of work. You guys will see as we repeat this over and over again, we're going to find out that this problem gets easier and easier for us because we're just doing the same thing over and over again. All right, the second column is done. Now the third column is our range column. The range is the x distance. So that's the x direction. So how do we find the range? Well, now we can say, okay, well, we have to look at these numbers. We have an initial velocity of 90. We have an acceleration of 0. We have a time, and we have a distance. So we have v, d, and t. Well, that's the easiest of all the equations. V equals d divided by t, right? And so 90, because we're going to use the x direction, equals d divided by 0.95. And so now we can solve for d by multiplying both sides by 0.95. And we get d is equal to 85.5. Right? Now the fourth column is our velocity column. So I always write the word velocity right here. And I make a split and I say I need my x and my y velocities. All right? So what's the x velocity? We just talked about it. If something is launched at 90 and there's no air resistance and nobody puts their hand to stop it, it's just going to keep going 90. And so there's really nothing that we need to calculate. Vx is going to be 90. When it gets down here, it's going to be going 90. Okay? Nothing's acting on it, nothing's accelerating it. Now Vy is going to be different because Vy we know is going to be accelerating. So we have to find the final velocity here. We have to use this equation. Vf equals Vi plus At. But what's Vi in the y direction? It's 0. What's A in the y direction? Negative 9.8. And what's T? Well, it's 0.95. And so it's a real simple equation of negative 9.8 times 0.95 to get our velocity, which I think is like negative 9.31 meters per second. All right, almost out of time. So the question becomes, do we want to do this over and over again? Because do we want to do we have the patience to do this over and over again? And you have to. Okay, you just have to. And the reality is once you do this problem over again, all these steps that were taking us 10 minutes become quick. We actually could get this down to about 2 minutes. So the reason why we have this problem going over and over and over again is all we're changing is the distance. We're changing this negative 4.5 to negative 10. Well, when you do this problem here, that's going to change that equation, and you're going to get a different time. And then you're going to do the same equation here, and you're going to get a different time, so you're going to get a different distance. And then you're going to do the same thing over here, and you're going to remember velocity, and then you're going to calculate a different velocity. And if you do that over, okay, 3, 4, 5 times to get to the end, okay, by the time you get to here, you will have remembered what the equation is for time. You will have remembered what the equation is for range, and you will remember how to find velocity. Not only because you've done it 5 times, but because of the location that it's at. And so when you get to the next page, where we have the same problem, but with 100 meters, what you're going to do is you're going to say, oh, wait a second, I don't even have to look back at this one. I don't even have to copy anymore. I remember it. I promise you, the majority of you guys will say, I remember the equations. And you will have learned a majority of projectile motion in 6 problems. You just have to be willing to accept that. All right, I'm almost done with my 15 minutes. If you have any issues, look at the key, but I'm going to post this video right now for you guys.